Welcome back to another deep dive. Today, we are going to try and solve a riddle that, well, it sounds a bit like a philosophical tongue twister, but it's actually the reason bridges stay up and software doesn't crash.
It's a riddle that costs billions of dollars if you get the answer wrong, so, no big deal.
No pressure then. The riddle is this. What is the difference between doing the thing right and doing the right thing?
It sounds like wordplay, doesn't it? Like something you'd hear in a corporate mindfulness seminar.
Totally.
But in the world of heavy engineering, systems integration, and these massive infrastructure projects, those two phrases they're two completely different, almost warring concepts.
I used to think they were synonyms, basically just don't mess up. But we've been poring over a technical specification document today. It's document E3.6 titled Employer Requirement Verification and Validation. And it turns out distinguishing between those two ideas is the entire game.
It is. This document is essentially the operating system for a mega project. I mean, whether you're building an offshore oil platform, a high-speed rail network, or, a nuclear power plant.
Right.
You need a rule book that stops the project from just collapsing under its own complexity. This text is that rule book.
So let's set the stage for you. We're looking at a template for a major contract, and the document throws around terms like FEED,
which is front-end engineering design.
Procurement and construction. We are talking about projects that take years and involve thousands of people.
And thousands of requirements. That's really the key. When you buy a toaster, there are, maybe 3 requirements?
If you toast bread, it doesn't catch fire.
And it fits on the counter. Exactly. But when you build a refinery, there are tens of thousands of requirements, from the grade of steel in the pipes to the software running the fire suppression system.
And our mission today is to unpack the strategy this document uses to manage all that chaos. It's called the V model.
Ah, the V model. It's legendary. It's really the mental map for this whole process.
But before we get to the map, we have to settle this duel between the two Vs: verification and validation. Section 1 of our source material is incredibly specific about separating them.
They have to be separate, because if you mix them up, you run the risk of what we call the perfect failure.
Okay, let's define them first. According to the source, verification is the evaluation of whether or not a product, service, or system complies with a regulation, requirement, specification, or imposed condition.
Which is a fancy way of asking, did we build it right?
Did we follow the recipe?
Exactly. It's objective. It's binary. If the spec says the wall must be painted Pantone Blue 286, and you paint it Pantone Blue 286, you are verified.
Check.
You followed the instructions, you get a gold star for compliance.
Okay, simple enough. Then we get to validation. The source defines this as the assurance that a product, service, or system meets the needs requirements of the employer and other identified stakeholders.
And there's the translation, did we build the right thing?
And that's the needs part. That's the key word.
Right. And this is where it gets dangerous. You can have a project that is 100% verified but fails validation completely.
Give me an example of that. I mean, how do you follow all the rules and still fail?
Okay, imagine you're hired to build a tunnel. The contract says it needs to be 10 meters wide, concrete lined, and located at specific GPS coordinates. You build exactly that. The concrete is perfect, the width is spot on.
So you're fully verified.
Totally. But the actual stakeholder requirement, was to divert water from a flooding river. And it turns out the tunnel is 10 feet too high to catch the water.
So you have a perfect, completely dry tunnel.
A verified but useless tunnel. That is a validation failure. You did the thing right, which is verification, but you didn't do the right thing, which is validation.
Wow. That is a nightmare scenario. And I assume this document, E3.6, is designed specifically to prevent that.
That is its entire reason for being. It forces those two concepts to talk to each other so you don't wake up 5 years and $1 billion later with an asset that doesn't solve the problem.
And the way it forces that conversation is through this V model. I want to try and visualize this for everyone listening, because the document references a diagram that is literally the backbone of the whole thing. So just imagine a giant letter V.
It's basically a timeline moving from left to right, but instead of a straight line, it dips down into detail and then has to climb back out.
Let's trace it. We start at the top left of the V. The source labels this side project definition and design.
This is the thinking phase. You start at the very top left with user requirements. That's the big picture stuff.
Like, we need to process 50,000 barrels of oil a day.
Exactly. Then you slide down the left slope of the V. The document lists the steps. basic design, then feed requirements, and finally, at the very bottom, detailed design.
So it's like a funnel.
It is a funnel. You start broad, and as you go down, you're breaking those big requirements into smaller and smaller pieces. By the time you hit detailed design at the bottom, you aren't talking about processing oil anymore. You're writing specifications for the torque on a specific bolt in a specific valve.
So we are deep in the weeds at the bottom of the V, the pivot point. And the source labels this procurement and construction.
That's the build phase. The noise, the welding, the physical reality. This is where you actually turn that detailed design into real hardware.
But we aren't done. The V model says we have to climb back up. Now we're on the right side, which is labeled project integration and testing.
And you can see the symmetry here. We went down into detail, now we climb back out. We start at the bottom right with integration and testing. That's checking the bolt. Then we move up to systems and subsystems.
Checking the valve.
Right. Then operation and maintenance, checking the whole pump assembly.
And finally, at the very top right, we hit project performance.
Which perfectly mirrors the user requirements we started with on the top left. We're back to asking the big question.
Does it process 50,000 barrels a day?
Exactly.
Okay, but here's the part of the diagram that really struck me. There are these dashed horizontal arrows. They connect the left side directly to the right side, cutting straight across the V.
Those arrows are the most important part of the whole graphic. They are the validation link. That's the magic.
Explain that. Because it looks like they are connecting the beginning of the project to the end of the project before anything has even happened.
That's exactly what they're doing. So, for example, there's an arrow connecting user requirements on the top left to project performance on the top right. What that tells you is that you don't wait until the project is finished to decide how you're going to test it.
So when I write the requirement on day one, I'm also writing the final exam.
Precisely. If you write a requirement that says the system must be safe, that's vague. The V model forces you to look across that horizontal arrow and define right then what safe looks like in the final test.
Does it mean 0 injuries? Does it mean it can withstand an earthquake?
You have to define the test on the right side at the exact same time you define the design on the left side.
That makes so much sense. It stops you from moving the goalposts later on.
It creates a closed loop. As Section 1 states, project integration, testing, and completion shall include verification and validation per phase. You are constantly looking across that V to make sure the left hand and the right hand are shaking on the deal.
So that's the theory. The V model is the philosophy. But what I love about this source is that it doesn't just stay in the clouds. It immediately pivots to bureaucracy. I mean that in the best, most necessary way. Section 2 introduces the VVP.
The verification and validation plan.
And this is not just a nice to have. The source says the contractor shall prepare this plan, and the timeline is, wow, it's aggressive.
No later than 30 days from the commencement date.
30 days. Just imagine, you just want a contract to build a skyscraper, you haven't even broken ground, and you have 1 month to submit a master plan for how you're going to verify every single nut and bolt.
It sounds harsh, but it's actually protection for the employer. They're saying, before you spend a dime of my money on steel, show me exactly how you are going to prove you did the work.
If you don't have a plan for verification, you don't really have a plan for construction.
You don't. And Section 2 makes it really clear that this VVP doesn't exist in a vacuum. It lists a whole ecosystem of other plans it has to align with.
It's the glue.
It's the glue that holds everything together. The source lists the engineering plan, the quality management system, the risk management plan, procurement, commissioning. The VVP has to weave through all of them.
Why is that alignment so critical?
Well, think about it. Imagine your risk management plan says, we need to mitigate the risk of saltwater corrosion. But your verification plan doesn't include any testing for salt spray on the paint.
You have a gap.
You have a huge gap. The VVP ensures that every promise made in those other plans has a corresponding test to prove it was actually kept.
The document also gets into the nitty-gritty of tools. It asks for a description of the requirements management system software to be used.
Right. And this is a nod to modern reality. You can't manage this on a clipboard anymore. You can't even really manage it in Excel if you're on a mega project. You need a dedicated database.
Because we aren't talking about 10 requirements.
No, we're talking about tens of thousands, potentially. Every single line in the contract, every regulation, every safety standard, they all get an ID number. And if you lose track of requirement, hashtag 4205, about the emergency lighting battery life, you could fail the final inspection. You need software just to track that complexity.
Which leads us perfectly to Section 3. I have to admit, this section gave me a bit of anxiety just reading it. It introduces the requirements breakdown structure, or RBS.
It's exactly what it sounds like. Just like a work breakdown structure organizes your time and tasks, the RBS organizes all of your obligations.
And the source mandates specific categories. You have to tag every single requirement. Is it performance, functional, design, procurement, construction?
It's all about filtering the noise. If I'm the construction manager, I don't need to see the administrative requirements for how to format monthly invoices.
Right.
I just want to know what I have to build. The RBS lets you slice the data so the right people see the right rules at the right time.
And once you have them categorized, they go into the requirements register. This seems to be the holy grail of the project, the living heart of the whole operation.
It is the scoreboard. And the document is very, very specific about the columns that must be in this register. It's not enough to just list the requirement itself.
No, let's look at those columns. You need a unique ID, okay, a source document link, the requirement text. But then it gets into the tracking. There's a column for verification action plan and one for verification report.
And this is the accountability loop. Verification action is your promise. You write down, I will verify the pump pressure by running a hydrostatic test for 24 hours. That's the plan.
And the verification report. What's that?
That's the receipt. You can't just check a box and say done. You have to hyperlink to the specific PDF, the lab report, the photo, the signed witness sheet that proves you did it.
So every single row in this massive spreadsheet eventually needs a piece of evidence attached to it.
Every single one. If you have 20,000 requirements, you need 20,000 pieces of proof.
And there is a status indicator column too.
Yes. Open, in progress, closed. It's binary. A requirement is open until you have that evidence linked in the report column. You can't sort of meet a requirement. It's either done and proven or it's not.
And you can't just hide the state of this register. Section 4 reporting puts a very firm clock on it.
Right. The contractor shall issue the updated requirements register on a monthly basis together with the monthly progress report.
Every single month. That must be a stressful day for the project manager.
Oh, it's the moment of truth. Imagine sitting in that meeting with the employer. You pull up the dashboard. If you're 80% through the schedule, but only 20% of your requirements are marked closed.
Everyone in the room knows you have a problem.
A big one. It effectively kills the whole we'll fix it in post mentality. You can see a train wreck coming months in advance.
Exactly. It forces transparency. You can't hide a backlog of unverified work.
You really can't.
Speaking of meetings, Section 5 brings the human element into this. Spreadsheets are great, but people actually have to talk. It mandates verification and validation meetings.
Right. Periodic reviews. And the rules are strict. You have to invite the employer 14 days in advance.
That seems like a really specific detail to include. Why does the document care about the invite notice?
Because the employer needs time to prepare. They need to review that register, look at the verification reports you've submitted, and come ready to challenge you. You can't just ambush them and say, hey, sign here, we're all done.
And the contractor is responsible for taking the minutes.
Minutes of meeting and reporting of these meetings shall be performed by the contractor. That's standard, but it's crucial. Whoever writes the minutes writes the history of the project.
Okay, there's one more sentence in Section 5 that I think is the ultimate gatekeeper. It says, the contractor shall perform and document a full verification and validation assessment for each project phase to be finalized before the start of the next phase.
That is the stop sign. It's probably the most critical control mechanism in the entire document.
Why is that so important? Why not just overlap the phases to save a bit of time?
People call that fast tracking, and it's so dangerous. Think back to the V model. You have phases, basic design, then feed, then detailed design. This rule says you cannot move from feed to detailed design until you have done a full V&V assessment of the feed phase.
So you have to prove you finished step 1 before you are allowed to even start step 2.
Exactly. It prevents something called technical debt.
Break that down for us. What is technical debt in this context?
Imagine you're in the design phase. You notice a pipe clashes with a structural beam in the 3D model, but you're in a rush, so you say, we'll figure it out on the construction site. You just let that requirement slide.
That's the debt.
That's the debt, because when you get to the construction site, fixing that clash might involve cutting steel, moving cranes, and delaying the whole team. It costs, say, $100 to fix it on paper. It costs $100,000 to fix it in the field.
So Section 5 is forcing you to pay that debt up front when it's cheap.
Yes. It says clean up your mess in the design phase before you make it real and expensive. It prevents what we call traveling work, work that travels from the cheap phase to the expensive phase.
It really paints a picture of a system that relies on, well, zero trust. It's not about trusting the contractor to do a good job.
Yeah.
It's about verifying every single breath they take.
It's trust but verify. Or in this case, maybe it's don't trust, just verify. The document isn't saying the contractor is incompetent. It's saying that complexity is the enemy. Even the best contractor in the world will miss things if they don't have this rigid structure.
So zooming out,
Mm-hmm.
we've gone from the V-model philosophy down into the 30-day scramble for the plan, into the daily grind of the register and the breakdown structure, and finally into the monthly meetings where all the decisions are locked in.
It's a comprehensive ecosystem. It really tries to close every possible loophole.
What stands out to you as the why behind all this paperwork? I mean, for a listener who isn't building a liquefied natural gas plant, why should they care about this?
It matters because it redefines what success even is. In, amateur projects, success is just finishing. In professional engineering, success is alignment. This document, E3.6, isn't just asking, did you build it? It's forcing a constant, sometimes painful check. Are we still building what we agreed to build?
It bridges that gap we started with, the gap between verification and validation.
It completely removes hope as a strategy. You don't hope the bridge holds the weight. You have a linked report in column J of the register that proves it holds the weight before you ever let a truck drive onto it.
I love that. Hope is not a strategy.
It really isn't, not when lives are on the line.
Bringing it back to where we started, that difference between doing the thing right and doing the right thing, it makes me wonder about how we apply this to our own lives, outside of engineering.
In what way? Are you suggesting we make a requirements register for grocery shopping?
Maybe. But I'm thinking more about life goals. We set these metrics for ourselves. I want to lose 10 pounds. I want to get that promotion. I want to buy a house by 30.
Those are the specifications, the requirements.
Right. And we grind. We verify. We hit the gym. We work late. We save the money. We achieve the goal. We are verified. The box is checked.
But I sense a but coming.
But then we get there and we realize we aren't actually happier. The promotion made us miserable because we hate managing people. The house is too big and we're lonely. We realize we chased the wrong metric. We failed validation.
That is a really profound thought. We spend so much time asking, am I doing this right? That we completely forget to ask, am I doing the right thing?
Exactly. Maybe we all need a personal V model. We need to look at our user requirements, what actually makes us happy, what our values are, and draw that horizontal arrow all the way to the final outcome before we even start the work.
I think you're right. Define the test for a happy life first, then start building the career or the life to match it. Don't just start laying bricks and hope.
If you're interested in the templates, please visit our shop. The link is in the description.
Thanks for watching. Please subscribe and see next time.